Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm back to work on this case steam engine governor that I'm working on for the Pioneer Harvest Fiesta up in Fort Scott, Kansas. This goes on one of their steam engines, a case traction engine, and they've had some issues with this governor, and I think we found just some slop and some general wear in it that we're just trying to take out in a couple places. I've already worked on the spool valve over here. We made a new valve stem for it, taken out some slop in that. The only other thing that I've really been able to find that looks like any kind of issue is on this upper part where we have this pulley. Ginger's come to check things out up here. Got this pulley here that spins, and basically this spins the fly balls up at the top, which is what allows that governor to adjust while we're working. This shaft through here runs in Babbitt bearings currently, and the bearings are fairly worn to the point that, it's not a tremendous amount of play in this, but there's more play in there than what I really like to see. So I think the game plan here is what we're going to do is, instead of trying to pour new Babbitt in this, I think I'm just going to put a couple of bronze bushings in it. I've got some bushings here that are 3/4 inch ID, which actually fits the shaft that we need. I'm going to turn these down a little bit to a little bit smaller outside diameter, so we don't have to, these are currently 1 inch OD, make these a little bit thinner. And I'm just going to take a reamer and kind of ream this out to match the OD size of the bushings and press these in, and hopefully we should be good. So that's kind of my game plan for today on getting this governor back up and going. Come along for the ride. Let's see how it turns out. Like I mentioned before, the shaft on this is a 3/4 inch shaft, are supposed to be, and it's got a little bit of wear on there. This shaft is a couple of thousandths undersized. And my original plan was I was going to replace this whole shaft. However, taking the little bronze bushings in here, these are also just a little bit undersized. That barely fits over the end down there, but once it gets in these areas, it actually is running really, really good. There's not really any appreciable amount of play in there, and you really want a little bit of clearance for oil anyway. So I think this shaft is going to be fine to just use like it is. Most of the wear is actually up here in these bushings, which was the Babbitt bearings. Now, this was poured solid from one end to the other with Babbitt, and again, a lot of wear, more so, I believe, out here on the outboard side, if I remember right. Doesn't really matter. Game plan, I think, is I'm going to just run a couple of reamers down through this, get this out to a pretty accurate size. The largest reamer I'm going to do is 27/32, which should give me just a thin shell on the outside of this for the bronze to press in place, which is all I need. And I'm going to turn the outside diameters of these bushings down to match so that we can have a nice little press fit in there. The biggest challenge is going to be getting this bottom one pressed in. I've got a bushing that's a little bit shorter, and I think that I can get something behind that, and using probably a clamp or something, be able to get enough pressure in there to push that one in place. Pressing the one in on this side is not going to be a problem at all. This one's going to be a little bit challenging, but I think we can do it just fine. So anyway, that's kind of the game plan. Leave as much original parts on here as we can. A little bit of a change here. It'll be supported on the ends, which is really all we need. And then what will end up happening is that center section in there is just going to become a big oil reservoir, which will really help keep this thing lubricated very well. So I think what we're going to do is head over to the radial drill, get this thing set up, and I've got two reamers. One of them is kind of in between where we're at now at a little over 3/4 of an inch up to this 27/64, and we'll do 2 passes with the reamers, and then we'll turn these bushings out to press in and see if we can get this thing fixed right up. Over at the Carlton radial drill, we're going to be using this to do our reaming on. I've got my governor piece kind of set over here in a vise. It's not tight. I really want this thing to kind of float a little bit. These reamers will follow that path that's already down through there if you give them a little bit of room to do that. If you clamp it super tight, since we don't have everything lined up perfectly, they're going to try to follow wherever you've got it clamped to. But if it's a little bit loose, that's going to be better. Which is why a lot of times in a lathe or a mill or something, when you're reaming, you'll actually use a floating reamer holder, where that reamer can float around a little bit and kind of find its own center. So we're going to try to do that by actually leaving the part a little bit loose. So let's get the radial drill. I need to raise it up a little bit. We'll just use the power lift there to get the head up where we'll clear our reamer over here. That should be good. And then I can then come in here and just kind of get it centered up. I can move the head around here and kind of get it over that hole where it will come down and start reaming. That's the game plan here. And I'm gonna probably leave this head a little bit loose where it can float around a little bit and kind of help find its own center. All right, let's get it reamed out. All right, I've got my drill kind of set on about the slowest speed I got, which is 145 RPMs. I'm gonna kind of bring this down and just start feeding down through that Babbitt. Hoping my reamer makes it all the way through. I have to re-chuck it. All right, that's as far as I'm going. Okay, and we are all the way through the bottom. Very good. All right, I'm gonna swap out cutters and we'll make another pass. I know someone's gonna ask about lubrication. It probably wouldn't hurt nothing, but this Babbitt is so soft, it cuts like butter. I'm really not too worried about lubricating this, so I'm just not worrying about it. And I think we're getting close to the bottom there. Still cutting though. All right, we're coming through the bottom right there. And I'm gonna just pull it back out. And I think we've got our reaming job done. Well, sometimes we have great plans and then we have to change our plans, and I think that's what we've just ran into here. So when I came over here and started looking at this, I realized that I had a chunk of Babbitt fall out of this back end over here as I was drilling that. I didn't really notice it until I came and looked in the hole, and I realized that the hole was off center. And yeah, when we were drilling that out, a big chunk of this Babbitt just kind of fell out. And that is going to really mess up my putting a bushing in here, because now my hole is not on center, it's off center, etc. So, as we often do, we're going to go to plan B. And what is plan B? Plan B is I'm going to heat the Babbitt, melt it out of here, and we're just going to pour Babbitt back in here like it was originally. Probably should have done that to begin with, but I honestly was trying to save myself a little bit of trouble. The bronze bushings I felt like was going to be a little bit quicker, easier way of doing it, and a little bit going to be just as good. But anyway, we're going to go back to the original and put Babbitt in here. So I'm going to go get this set up, and we'll get the torch out. We'll melt this Babbitt out and get set up to pour new Babbitt on a new shaft. I've got this piece over here just kind of hanging in a vise, and I got my ladle down beneath it that we can melt the Babbitt into and collect it. So I'm going to use a rosebud here on the torch and melt that Babbitt right out of there. I'll just kind of send the flame down the little hole here. And it's already melting and collecting down there in the bottom. I think we about got it. I don't see any more metal dripping out. So we'll stop. And I'm just going to let that cool down before we even try to do anything with it. It's going to be too hot to handle for a little bit. So this has cooled down. Still a little warm, but we can handle it. Kind of show you my setup. I've gone and just got a piece of 3/4 inch rod. I'm going to use this as a pouring mandrel to pour on. And this is the size of the shaft that we got going in there. On this end, of course, we're going to have our gear. I'm going to kind of use this gear to align everything in place. So we're just going to go ahead and put our shaft through here. Get that gear up onto the end of the shaft. All right, we got it in place there. I'm going to use some of my damming material for the Babbitt to kind of position this where I want it to get a little bit of backlash in those gears, not much, and kind of hold it in a position here and kind of get that centered up. Now on the other end, what I did is I went over to the lathe and I just made a little bushing here. And what this bushing is the inside diameter fits up over the shaft, 3/4 inch, and I cut a little shoulder on there that fits on the inside diameter of this hole. So now this bushing will center it on this end, and this will also serve as a dam to help keep the Babbitt in while we're pouring. And of course, we'll put the damming material around it as well. And our shaft will be positioned, and we'll just pour through the hole here where the oil goes in, was the plan. So I got a little set screw in there. Let me go ahead and tighten that up. Whoops. Go ahead and get that good and tight on that shaft. And I'm going to go get my damming material and we'll get everything positioned. That damming material will allow me to position this shaft and get it where it wants on the other side. And like I said, we'll dam everything up so the Babbitt doesn't run out. And I think we'll be ready to heat this thing up and pour some Babbitt bearings. This will be should be a fairly simple pour. I maybe just curse myself by saying that, but should be pretty easy. All right. I've got my Deacon mold pack here. This is what I use as a damming material. I've shown this when I pour Babbitts before. It's kind of a, I don't know, kind of like a Play-Doh. It's got a little like fibrous in it. It does not have asbestos in it. I know everybody always asks that. This is asbestos free, but it is heat resistant and it's made for doing exactly what we're using it for here, which is damming up for Babbitt bearings and other applications like that. So what I'm going to do is I'm just going to kind of wrap this around the joint here where these come together and where that Babbitt could pour out. It makes it, kind of seals everything up and keeps the Babbitt in place. I'm also going to put some up underneath the bottom here and kind of use it to position everything into place, because it does need to raise up just a little bit down here on the bottom. So let me get a little bit more in there. All right, I feel pretty confident that that's going to keep that molten Babbitt from pouring out around this end. And yeah, I think that feels good there as well. All right, we'll do the same thing on the other end here. Just get plenty of material around here. Again, the collar will hold most of the Babbitt in, but it's still, when it's liquid, it'll want to leak out around there, and then you're just dumping your Babbitt all over the table, all over your work, and it won't stay in there, and then you have to melt it all out and do it again. So I'd rather avoid that as much as possible. All right. I feel pretty good about that. So I think now I'm ready to get my Babbitt heated up, get the shaft kind of preheated, and see if we can get us a good pour here. Let me get this out of the way. All right, I think we're about ready to go here. I'm going to get my torch going. And first thing I'm going to do is fire up my stove over here. Got a camp stove with the Babbitt in it. I'm just going to use the torch to kind of go ahead and get this melted and let it be warming up and simmering. All right, while our Babbitt is heating up, I'm going to go ahead and start putting a little heat into this fixture here. I like for my Babbitt to be, or my bearing shell and all that to be preheated about 300-400 degrees. It just kind of helps the Babbitt flow around it very uniformly without chilling too quickly. If it's cold pouring that in there, it can freeze up and you don't get a pour the entire length of your pour, particularly on something long like this, and where you got a very small cross section of Babbitt that's going to be poured in there. It's going to be a solid pour. We're doing the top basically all in one pour here all the way around, so it'd be nice to have a little bit of heat in there. I'm going to have to repaint this, so I'm not worried about the paint blistering off or anything like that. I also want that shaft on the inside to be pretty warm. And I can tell I got some heat radiating out the ends there. And here we go. We're just going to pour it right down the hole here. All right, we'll let it cool down. All right, we got this in the vise. See if we can, yeah, just kind of get that turning. I'm just going to turn it a few times in here and see if we can kind of get it where it'll come on out. And with that, we'll take it back out of the vise and we'll see if we can extract that piece out of it and check out our pour. And see if we can just work this out. This gear is going to come loose here. All right. See if I can get that out of there. There it comes. All right, now I think we can get it on out the rest of the way without any trouble. There we go. And I'm going to take the original shaft here and see if I can put it in here. It actually feels really good. Much better than it was originally. So I think what I'm going to do, instead of using the new shaft, we're just going to keep the original shaft. The idea here being that this bearing pour is a little bit tight, which is normal. When you pour Babbitt, it's going to be a little bit tight. You need to get in there and scrape it out. But the shaft, the original shaft, is worn just a little bit. So that's going to actually turn in that new shaft. Very nice. So I like the way that feels. So I think what we're going to do is just going to kind of go with it. I do want to get this cleaned up. I need to drill out the hole up here where the Babbitt has filled up the oil hole. Get that cleaned up where we can get oil back in here. And I think this will be ready to reassemble. But I'm happy with the way our Babbitt pour turned out. It is still just a little bit stiff. I may run a reamer down through there just to kind of open it up a little bit as well, because it is a little bit stiffer than what I want, but it's pretty close. All right, we've got a 3/4 inch reamer here. I'm just going to kind of get it down into the hole, and I'm just going to run it all the way down through, and that hopefully will open that up just the least little bit, so that that shaft will go through a little bit easier. All right, it's all the way through. Much, much better. No play in there at all. Spins nicely. All right, I need to get this drilled out, and I think we'll be ready to probably put a coat of paint on it first and then reassemble everything. We're just going to drill this Babbitt out. I'm trying to stay out of the threads. This is a little bit smaller than the hole size for a 1/8" pipe tap, which is what we got here. And I got a pipe tap here. I'm just going to kind of go down and try to reform those threads. We really didn't drill the old threads out, but the Babbitt is kind of holding it, is in there, so I'm just kind of cleaning these up, kind of rechasing them. Let's see what that does. This is our oiler, and that's going to screw in just fine. All right. Up next, I need to clean this up real good and get a fresh coat of paint on it. And once the paint dries, we'll try to put this back together. So before we put all this back together, I want to start by repacking this gland. I had mentioned in the previous video that we need to get some packing material to go down in here. So this is basically the valve that moves up and down. There's steam up underneath the bottom, so we got to keep that steam in there. And the way we do that is you put a little packing around this gland, and then when you tighten this down, this little thing here compresses that, and as it wears, you just keep tightening it up. So when you start getting a little steam out of it, you tighten it up, but eventually you have to put some more packing in there. Now I went out and got just a little bit of packing here. It doesn't take a whole lot, and you just kind of wrap this around. I'm going to cut it off where it makes a circle there, and we'll pack that down in it and get her going. All right, got that in there now. So now I can drop that little piece back in there, and when you tighten that up, it'll just kind of cram it all down in there and tighten it up. Let me get a wrench and do that. All right, let's see if it'll take another round of packing. As long as I'm doing this, it's fairly easy to do it now. I'm just sitting here looking at it. See if we can get this down in here too. This packing is basically just kind of like a rope type material, and it's got graphite on it to help lubricate it. All right, I think we got that on there again. Tighten our nut up, and that'll press it on in there one more time. Very good. Let's see, kind of, yeah. So it's got plenty of room in there to tighten up as that goes. You know, like I said, when this thing starts leaking steam around there, you just come take a wrench, tighten it up, give it a little turn on there until it stops, and as it wears, it'll wear out. There's some packing left over. All right, that looks good. Let's move on here. I want to go ahead and get this put back together now. I'm going to put a little oil up inside that hole where the Babbitt bearings are. Yeah, that's going to be good. And I got a tapered pin that's going to go in there. Let me go find that real quick. I'm going I'll slide this back out here just a little bit. I can get the gear in, and we'll slide the gear up on there. And there is a hole all the way through this, and I was thinking it was a tapered pin, but then I remembered, no, it's a straight, looks like a rivet. But that's what was originally in here. That's what we're going to put back in it. If I can get it lined up, I'm going to need a hammer to drive that home. All right. That's good. Need to go ahead and get the piping back in here. If I remember right, it wouldn't spin off with everything up above it, so I'm going to go ahead. I got this over in my vise. I'm going to put a little thread sealant down here on this pipe threads. Put this back in here. It needs to be pointing towards the camera when it's tight. About another quarter turn here. Over on the top side of this now, the top piece just got leaned up over here. First off, I'm going to put this stem down in here. I want to get this all back together. There's a bevel gear that just kind of screws up on this. This helps you adjust your speed, I believe. I'm going to go ahead and just kind of screw this bevel gear up on there a good little bit. And then this part is going to come on next. And let me think here for a second. This is going to go on actually in this direction, and I want my handle to be coming out this side. There's a little pin in there that lines up in this groove right here that kind of holds that in place. So I'm going to spin that around to the back side. Get that lined up. There we go. Now, when you turn the knob, probably in the way here, but when you turn the knob, it adjusts that bevel gear up and down. And I think we are ready to go ahead and kind of drop this back on top here. Handle here goes in. Again, we got that little tapered pin that connects to the valve stem. And I need to get all that lined up as well. That kind of lined up. And that pin has got them connected now. I'll tap that together here in just a minute. Now, there's a couple of set screws that mount on the side and the back of this that kind of hold this top piece. You can pivot it around to adjust your belt where you want it. You can put it in any position on here you like, but this is the way it was. So I'm gonna go ahead and get these tightened up, and that'll prevent that from moving around. So next we got to put this whole linkage in here in place, and I realize right this minute that I got a problem. This has got to go in before this pulley goes on, so I don't know if I can pull that pulley off the end or whether I'm just going to have to pull the whole shaft out. We'll try to get the pulley off, but I don't know. We'll see. Here it comes. Let's see if we can tap this off. Yeah, that's going to be the easy way. All right, let's do this again. We're going to start by putting our piece in. Next comes the little ratchet pawl there. Then we're going to put our spring in place. I'm going to kind of get our shaft pushed through here some. And now we need to compress the spring. And I've got a little spring compressor here. This is for like a small engine or something, small valves on a small engine. Let's see if I can make this work. It's not really made for exactly this application, but maybe we can fool it into working. All right, let's see if we can get that in there this time. And I'm going to now kind of let my spring pressure come back out. I'm lining my pin up. There it goes. All right. Now what this does is this puts tension on the valve. Again, this piece over here is raising and lowering it, and we tension it with this spring and this pawl. So I need to get this piece back in here to catch it, and then we can tension this, and that's going to put upward pressure on the valve, because you want the valve to be open whenever there's nothing going on, and then as the balls start turning in the top, it will actually close the valve and kind of find the speed that you want to set it on. So let's get this little pawl back in place, and we'll have that part done. All right, I think we got it now. Here we go. And we'll drop a little cotter pin in right here to hold that in place. I'll keep that from coming out. All right, so now we need to tighten up this spring to get the proper tension on it. Here we go. So you just tighten this up, and I gotta let that, there we go. So you can see that's pushing pressure up on there. Now the actual amount of tension that we want to have on this is going to probably need to be determined once they kind of get this thing set up and going. I'm going to take it off just a notch. They'll have to adjust that on the fly on the steam engine, but we've got it where the tension is pushing it up right now, so that's good. All right, it's looking good. I think we're ready to continue on. We're going to put the balls up in the top now. So I'm going to put a little dab of oil up here on that little bearing surface there. This will come over the top, and this is what the little fly balls are going to go on. I'm working on putting these fly balls up here on the top. It's just basically put it in place. You got a pin that goes through here, and then we just put a cotter in that. Now I need to get the bottoms, and I'm going to have to kind of push down on things to get them lined up here. There we go. I'm going to go ahead and get them all in, and I'll set my cotters. All right. right. Now as the centrifugal force pulls these balls out, that lowers your valve down here and kind of closes it down. But with that, we're pretty much all set back up and running. That's running just as smooth as can be. Our valve is ready to go, and of course you can adjust the height of the valve with this little handle on the other side. But that is all put back together. All right, guys, with that, I think we got this governor back together, and it appears to be in good shape. Hopefully they can get the little issues. This is going to fix the issues that they were having with it. I really don't see anything else that's really wrong with it, other than maybe just needing to be adjusted out, you know, just exactly right to get the valve height set right, the tension on this spring set right. There's some little adjustments you got to make to get this thing fine-tuned, but it's in good shape. The valve was in good shape. Like I said, we replaced that valve stem in there. We worked on the bearings over here. I mean, this thing ought to be good to go. There's really nothing that I can tell that's wrong with it from this point forward. So we will work on getting this back out to those guys. I need to touch base with them, see how they want to do it. They actually had one of their members bring it down to me all the way from Fort Scott, Kansas. I'm not sure if they're wanting to pick this up or have it shipped, but we'll work that out and get it headed back their way, because they got a show coming up in October, and that'll hopefully give them time to have a chance to get it installed and get it checked out and get it all tested beforehand to make sure everything's worked and fine-tuned. So with that, that's going to be a wrap. As always, thanks guys so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. Big, huge thank you to all those who support the site financially through Patreon, PayPal. Links for that down in the description. If that's something you want to help out with, that's greatly appreciated, and it does enable me to take the time to shoot these videos and be able to bring them to you guys. And with that, we're going to sign off. We'll catch you on the next video. Again, thanks for watching.